today we're going to talk about angles of polygons. We're talking about both the interior and exterior angles that are included with these types of polygons. But first, we should probably review what a polygon actually is. So I'm going to show you some examples and then some non-examples, and we're going to kind of talk about what we have of each. So we have some examples, and then we're going to have non-examples, and we're going to see which ones, what are differences. So here's some examples of polygons. Okay, we have some different versions here. We have all of those. Now some non-examples. Okay, now forgive my drawings, right? And that. All right, so when we're talking about our polygons, there are different things that we need to think about. And looking at our non-examples and our actual examples, I'm going to write down some things about what a polygon is, and then we'll discuss further. So a polygon has no curves. There are the vertexes meet once. And what I'm talking about that is if you're looking at this figure over here that has an X through it, that is not a polygon because we see that it meets in the middle. That's not okay. And we have to also make sure that there are a closed figure. Okay, so those are all of the things that create a polygon. So we know common polygons such as squares and rectangles, triangles, those are all polygons, but we also don't have to have exact figures. So this weird star-shaped one that I made, this one, it has vertexes, no curves, and it doesn't really look like a star because it's missing that one arm, but the vertexes all meet once, and it doesn't have to be a regular polygon, and we'll talk about that later. Now, let's talk about the interior measures of a polygon. There's actually an equation that we're going to start working with, and in order to get the sum of the interior angles of a polygon, I'm going to write the equation and explain it. So we have S is equal to n minus 2 times 180. So let's talk about what each of these mean. Well, first off, S, that's the sum. Okay, so that's when all of the angles, the interior angles, are adding together. N is standing for the number of sides that the polygon has. Okay, so all you have to do is plug in the information that we have to find out the information that we need. So I'm going to jump right into our first example. It says find the sum of the interior angle measures of the figure. So we're using this pedestrian sign, and we know that it has 1, 2, 3, 4, 5 sides. So the number of sides that we're going to plug in is 5. We are looking for the sum, so we can't plug anything in for S. So we put it into our equation. We have S equals the number of sides, which is 5, minus 2 times 180. Using order of operations, I go ahead and do the parentheses first, so it's 3 times 180 that's left. So I find out that the sum of all of my angles, all 5 of them, is going to equal 0, 4, it's going to be 540 degrees. So all 5 of these angles, no matter what they are, have to add up because it's the sum, and they have to equal 540 degrees. Now I'm going to jump over to the honeycomb example over on the right, and I'm counting the sides for this one. 1, 2, 3, 4, 5, 6. So the number of sides is equal to 6, and that's what I plug into my equation. So S equals 6 minus 2 times 180. So 6 minus 2 first because we're using order of operations. It's 4 times 180. Then we go ahead and find the true sum of all 6 of these angles together, and we get 720 degrees. So all 6 of those angles, no matter what they are, have to add up to equal 720. Go ahead and find the spider web's interior angle sum using the same process. Now we're going to go one step further where we are given some interior angles. However, we don't know the one angle that's left, the x. So let's look at the green figure first. First off, these aren't regular polygons. They have different sides, and that's okay. So we're going to count again how many sides each figure has. So this one has 1, 2, 3, 4, 5, 6, 7. So we know that the number we're going to plug in for the number of sides is 7. And we're going to go ahead and start finding out the sum first. We got to find out what all of these add up to first. So we do sum equals, we have 7 minus 2 times 180. Okay, so we're going to go ahead and now do 5 times 180 to find out what the entire interior sum is going to equal. So when we go ahead and do that, we get that the sum is equal to 900 degrees. So all of these guys have to add up to equal 900. Now we have to go again one step further. So to find this missing piece, this x, we need to figure out what all of these angles added together are equal to. I'm going to use a little bit of mental math by crossing off some and adding them together. I'm going to start with 140 and 145. Those are equal to 285. 128 and 130 is equal to 258. And then 115 plus 120 is 235. This is just so it's a little easier for us to add things together. So we go ahead and add these up. This becomes 13. We carry the 1. 9 plus 5 is 14. So that's 17 over here, and we bring it over, and that's 773 degrees. So all of those angles, except for that one missing piece, x, equals 773. So all we have to do at the end now is do 900 minus 773 to find out that missing piece. We go ahead and borrow and make sure we do our math correctly, and we get that that missing piece, that x, is equal to 127 degrees. To check your work, you just need to add all of these angles up and make sure that they equal that sum 900 degrees. I'm going to jump down and work on this blue diamond shape, and we're going to do the same process. So the first thing you have to do is find your sum. So we need to know what all of these blue angles are going to add up to equal. So let's count the number of sides. 1, 2, 3, 4, 5. So the number of sides of this figure is 5. So we plug it into our equation. Sum is equal to 5 minus 2 times 180. So we subtract 2 from 5 and get 3 times 180. And just as we did in the problem before, we get 540 degrees. So all of these angles have to add up to equal 540. Now this is a little different because we have two x's on each corner. So I'm going to create an equation this time. So I have 2x plus 2x plus 145 plus 145 plus 110, and we know that all of those guys have to equal 540 degrees. Now we need to combine our like terms so that we can have a better knowing of what we need to do. So 2x plus 2x, that's 4 x's. Okay, 145 plus 145, these two create 290, and then I add 110 to that, so that becomes 400, and it's equal to 540 degrees. So all I did is combine all of my like terms. Now it looks like a little simpler multi-step equation. So I draw my wall, and I need to get rid of the 400 and the 4. The 400 is the first thing to go on the left side, so I subtract it because it was adding. That goes away, and I have to subtract it on the other side as well. So I'm left with 4x equals 140. Now I go ahead and divide by 4 because 4 is multiplying to x. So we get that x is equal to 35 degrees. Now that's what the value of x is, okay? So if I wanted to check my answer, I would plug it in, and you guys can even plug it in to this equation right here, okay? So you could do 35 times 4 and make sure that when you add 400 to it, it equals 540 degrees. Go ahead and find the next two examples on your own. First, you find the sum of all of the angle measures, then find the missing piece of x. Now, regular polygons are different than just general polygons, because regular polygons mean that all of the sides and angles of that specific shape are equal or congruent. We know that word very well now. Okay, so these are the typical shapes you see. Typical hexagons, polygons that have the same size and angle measures. Those are the ones we see on street signs, and those are the common ones that we learned about when we were younger. So we know that all the angles are the same. Let's look at the first example. A cloud system discovered on Saturn is in the approximate shape of a regular hexagon. Find the measure of each interior angle of the hexagon. So a hexagon has 6 sides. So we need to know what the whole inside is equal to if it has 6 sides. So we just got our n. Go ahead and plug it into the equation of s equals 6 minus 2 times 180. Okay, so our sum is equal to 4 times 180. And I'm pretty sure we've already done this in the video, but we end up getting 720 degrees. If the sum is equal to 720, we know that all 6 sides and also 6 angles, if there's 6 sides, there's also 6 angles, we know that they're going to be the same. All you have to do is do 720 divided by your 6 angles evenly, and that's going to give us our answer. The answer that we get for each angle measure is going to be 120 degrees. So each angle measure, each one is 120 degrees. All you can do to check your answer then is do 120 times 6. You should get that 720 degrees. Go ahead and try the next 3 on your own. Think about how many sides an octagon has, a decagon, okay? And of course, an 18agon has 18 sides. So you're going to find the interior sum total and then divide it by the amount of sides that you have. Exterior angles of polygons are pretty simple because every single time they have a sum of 360 degrees. Think about it. If you're walking around an entire figure, you create a circle. Now that's not the best circle, but you do create a circle which is a 360 degrees. So no matter what shape it is, all of the angles have to equal 360 degrees. So I'm going to jump and go to this yellow figure on the end, and we know that all of these angles have to equal 360. So I have an X right here and another X right there. Now I have this box, which we know means 90, another 90, and another 90. And we know it has to equal 360 degrees. So now we just have to find our missing piece. So we have 2 X's and we have 270 from 90 times 3, and it's equal to 360 degrees. Now we just have to solve for X. So you draw your wall and subtract 270, and when we get that answer, we have that 2x, because that cancels out. 2x equals 90. Now you divide by 2, and x is equal to 45 degrees. So this x is 45 degrees, and this one is 45 degrees. Please do the other 2 on your own. Now I'm going to give you a hint for the red figure. It says find the measures of the exterior angle. So once you find what z is equal to, especially on this angle, you got to plug in z and then find the true angle of what that is. So you're just going to add 26 to it. So go ahead and find those. Remember, they always equal 360 degrees.